Hi all. Today we are going to conduct experiment on three-phase induction motor. So let us see all our brake test earlier experiments. You might have seen how to take the readings from S1, S2 weights and the speed of the motor. Everything is similar to all experiments. Today I would like to explain about the connections of the three-phase induction motor. And in another video I have explained the working principle of the motor. As a three-phase induction motor is consisting of three individual coils. All coils are connected to three individual phase supplies. RYB is connected to RYB. That's only connections. To calculate the efficiency, we need to take the power consumed by the each coil when motor is loaded. So there are two wattmeters are provided on the panel and a voltmeter and ammeter is provided. Voltmeter is always connected between any two phases. So first you connect voltmeter two terminals to any two phases. You refer the circuit diagram. So any two phases you can connect RY or RB. According to circuit diagram you can give. So now a voltmeter is connected. Connect long wire. Right. From this phase, take a loop wire and connect to M. This is the wattmeter. It consisting of a current coil between M and L, which will measure the current. It consisting of a potential coil between CV. So potential coil will measure the voltage. So this particular meter is consisting of ammeter, voltmeter and cos phi meter also. In AC, inductive loads causes angle between voltage and current. We need to consider the angle also while calculating power. P equals to VI cos phi. So this meter will measure VI and cos phi also. So it is having terminals of MLCV. So directly I am connecting this phase to M coil means line common voltage. So this is common means M to C should be short circuited. M and C. Right. This L is connected to R of the motor. Next, coming to Y phase. From Y phase you connect to ammeter. We need to take the ammeter reading in one phase. So ammeter other terminal is connected to Y. Ammeter other terminal is connected to Y. So since it is a three-phase power, we need to consider any two phases power. So another wattmeter is provided in the B line. So it should come to this M. It should come to this M. Same connections. Main is connected to common. Main is connected to common. L is connected to B. This L is connected to B. So now you see, two wattmeters are connected in two phases, R phase and B phase. It will give the power consumed by the R phase and B phase, R coil and B coil. What about this Y coil? There is a mechanism for that. So if you connect V and V voltages of wattmeters and connect it to Y, so this will add Y phase power also. So W1 and W2 will add the Y phase power also. For that we have a special connection, that is VV short circuited and connected to Y. V and V of the wattmeters W1 and W2 and take a loop wire and connect it to Y of the motor, so that it will measure three coils power. Right, this is only the connection. Once again I will explain. R phase is taken to voltmeter, Y phase is again taken to voltmeter. From R phase it is connected to M of the wattmeter, MC short circuited and L is connected to R. And Y is connected to voltmeter second end. Same Y phase is connected to ammeter. Ammeter other terminal is taken to Y. B, same, B is taken to M of the second wattmeter and wattmeter is taken connected to common terminal. L is connected to B phase. And one more connection I have explained you, and V is connected to V and this V is taken to Y phase to add the power of the Y coil also. This is only the connection. Now keep it in minimum position and switch on mains. So let the meters comes to their 0 position. Then you start applying the voltage from 3-phase variac. Slowly apply and observe the motor. Remove the load on the motor first. So now motor is rotating. So by taking 3-phase voltage, till what voltage we have to apply? First phase voltage will be 415 volts. Till that voltmeter reads 415, you go on varying the voltage. 415. Yes, that's enough. So rated voltage is applied. By taking rated voltage, if you measure the speed of the motor speed always little less than synchronous speed, as I have already explained you in the previous video, because to maintain the slip between rotating magnetic field speed and rotor speed. So it approximately 1480, and the procedure will be same. You have to take the readings of voltage and current is 3.1. The rated current of this motor is 4.5. So within 3.1 to 4.5, we will carry out 3 to 4 readings, and W1 is reading it since it is in kilowatts. W1 showing second division, that means it is 200, and the first power will be no load condition, it will show negative power. So the deflection will be downwards. So we have to take approximate negative power from the second wattmeter. After loading, it will come to positive levels. So go on gradually loading for different currents of ammeter. So let us keep 3.5. Let us adjust the ammeter current to 3.5 by loading this. Now 3.5, you can take the speed of the motor and you can note down the weights from this, and voltage current W1 is this, and this came to 10 positive deflected, and again set another current 4 amps. So for that 4 amperes of load, take the speed of the motor S1, S2, weights of S1 and S2, and voltage current W1, W2 readings simultaneously taken. It is advised to pour the water into the drum to avoid the heating of the winding coils. By loading this, it will produce the heat, and that should be compensated. Always used to pour the water into the drum to cool it, and again increase the current to 4 and take the readings of all this, and increase the current to last maximum current point, that is 4.5. It is the rated current of the motor. It can bear up to 4.5 amperes of current only. This is the last reading S1, S2 speed, voltage, current, W1, W2. So after that, decrease the load on the motor and set it to 0 position, right? Decrease the voltage. Switch off.